So hello again, class. Engineer Queen here. So for today, we're to continue class. So we're to discuss. This would be part 6 of module 4. Okay, so share ito ulit. Okay, so again, class, we continue with testing of concrete na tayo. Okay, so pasadahan ko lang guys. Tapos, usually we have a video again for this one and then I'll summarize. Proceed. Okay, so yeah. So unahin natin class, so workability na. So the very definition of class of workability is the property of concrete. Which determines its ability to be placed, compacted, tsaka finished. Okay, tapos there are certain factors affecting workability. So meron tayong, ilan ba yan? Total of 6. Okay. So water content class, mixed proportion, aggregate size, shape of aggregate. Tapos grading, and lastly class is the admixture. Okay. So yun muna class, and then we watch the video regarding the factors and the definition class of workability. I'll summarize and then we'll proceed to the next one. Okay. So, dito na tayo class sa testing. Workability. Ito. Factors and workability.
Workability of concrete.
Wait lang. Okay. So, yan. Reset. Okay. So, again, class. Tune in tayo, class, for the discussion on the workability and the factors affecting it. Okay.
Workability of concrete. An ideal water-cement ratio alone not going to give maximum strength. A 100% compaction of concrete is an important parameter for contributing to the maximum strength. Insufficient compaction will result in presence of air voids whose damaging effect on strength. Generally, to compact the concrete fully, a higher water-cement ratio is adopted. The water functions as a lubricant in the concrete which eases the compaction process. Thus, water is required for handling concrete without segregation, for placing without loss of homogeneity, an effort of compaction required to finish the concrete easily. The quality of concrete satisfying all these requirements is termed as workable concrete. Thus, the term workability of concrete is defined as the property of freshly mixed concrete which determines the ease and homogeneity with which it can be mixed, placed, consolidated and finished. Every work requires a particular workability of concrete. Workability of concrete can be divided into 3 different types: low workable concrete, medium workable concrete and highly workable concrete. We will discuss these in another video. A comprehensive knowledge of workability is required to design a mix. To get a right workability of concrete, one must have the proper understanding of the type of work, the distance of transport, loss of slump, the method of placing, and many other parameters involved. Right workability of concrete will make the concreting operation economical and durable. Let us now see some of the famous definitions of workability of concrete. Road Research Laboratory, UK, who have extensively studied the field of compaction and workability, define workability as the property of concrete which determines the amount of useful internal work necessary to produce full compaction. Another definition which envelopes a wider meaning is that workability is defined as the ease with which concrete can be compacted 100% having regard to the mode of compaction and place of deposition. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and
So yun na class, yung para introduction regarding workability of concrete. So next up class, we're to discuss na yun na, yung factors affecting workability. Okay. So continue with
finally,
the video.
don't forget to subscribe our channel. Factors affecting workability of concrete, Part 1. The term workable concrete denotes the concrete which exhibits very little internal friction between particles or concrete which overcomes the frictional resistance of the formwork surface or reinforcement contained in the concrete with just a considerable amount of compaction. The factors affecting workable concrete are water content, mix proportions, size of aggregates, shape of aggregates, surface texture of aggregate, grading of aggregate, and use of admixtures. Water content.
So yun yung class, no? First factor. So she, ma'am, engineer will tackle. Yeah. First factor, water content.
The amount of water content available in a volume of concrete will have a significant effect on the workability of the concrete. The higher the water content per cubic meter of concrete, the higher would be the fluidity of the concrete. In general, to increase the workability of the concrete at site, certain amount of excess water is added. However, it should be noted that increasing the water content of concrete will to have some effect on strength of the concrete. Thus, an addition of more water is considered as a last recourse. Besides, whenever more water is added, a certain amount of cement is also added, so that water-cement ratio remains constant. Mixed proportions. In general, aggregates.
So ito na yung second factor, class, mixed proportions. Okay, so again ulit natin.
Cement ratio is also an important factor which influences the workability of the concrete. If the aggregate cement ratio is higher, the lean concrete is formed. In this case, less quantity of paste is available for providing lubrication. Hence, workability is reduced. Whereas, if the aggregate cement ratio is lower, the rich mix is formed. In this case, more paste is available to provide lubrication. Hence, better workability of the concrete is observed. Remaining factors we will discuss in the upcoming videos. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. Factors affecting workability of concrete, Part 2. Size of aggregate.
So ito class yung third factor natin, specifically class the size of aggregates. Okay?
Bigger the size of the aggregate, the lesser is the surface area. Hence, less amount of water is required for wetting the surface. Thus, less paste is required for lubricating the concrete surface to reduce internal friction. Thus, we can say that the bigger size of aggregates will give higher workability. Reduction in size of aggregates will reduce the workability. Shape of aggregate.
So ito na yung fourth factor natin, class, affecting workability. So specifically class, shape of aggregates.
The shape of aggregates is also have considerable influence on the workability of concrete. Compared to rounded aggregates or cubicle-shaped aggregates, the angular, elongated or flaky aggregate makes the concrete very harsh. Thus, rounded aggregates have better workability. This is due to rounded aggregate will have less surface area and less voids than an angular or flaky aggregate. In addition, rounded aggregate has the reduced frictional resistance. This is a reason why river sand and aggregate provide greater workability of concrete than crushed sand and aggregate. Besides, the shape of aggregate also has a significant effect on strength and performance of concrete. In recent times, usage of natural sand is restricted, thus new machine was designed to yield well-shaped and well-graded aggregates. Surface texture.
Okay. So fifth class is yung wait. Technically pala class, kasama pa rin yun sa shape. Shape and texture pa rin.
The surface texture of the aggregate.
So 4B factor.
Aggregate also has significant effect on the workability of concrete. The total surface area of roughly textured aggregate is more than the surface area of a smoothly rounded aggregate of the same volume. Thus, it can be inferred that roughly textured aggregate will show poor workability and smooth or glossy textured aggregate will give better workability. A reduction of interparticle frictional resistance offered by smooth aggregates also contributes to higher workability. Remaining factors we will discuss in the upcoming videos. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. Factors affecting workability of concrete, Part 3. Grading of aggregates. This is an important factor which...
So yun class, no? So fifth factor affecting workability, grading of aggregates. Listen to the video.
Has maximum influence on the workability of concrete. A well-graded aggregate has the least amount of voids in a given volume. Thus, when the total voids are less, an excess paste is available to give better lubricating effect. With the excess amount of paste, the mixture becomes cohesive and fatty, which prevents segregation of particles. Thereby, the aggregate particles will slide past each other with the least amount of compacting efforts. Thus, the better the grading of aggregate, the lesser would be void content and higher the workability of concrete. Use of admixtures. The use of admixtures is also have a greater influence on the workability
Ayan. So last factor class, no, is yung admixtures. So
of
continue the
concrete.
video.
In general, the plasticizers and superplasticizers greatly improve the workability of concrete. Use of air entraining agent being surface active reduces the internal friction between the particles. The air bubbles act as a sort of ball bearing between the particles to slide past each other and give easy mobility to the particles. Similarly, the use of fine glassy porcelainic materials increase the surface area and offer better lubricating effects for providing better workability. We will discuss the different admixtures later. Thank you for watching. Stay tuned. The best.
So yun, class, no? So titignan nyo, props payment sa video. Again, class, credits to anime_edu YouTube channel for the very well detailed discussions. Okay? So again, kasi summarize natin. Okay? So, di ba, we talked about so dito na tayo testing of concrete. Okay. So, first step class, di ba, meron tayo ng 4.11.1. Okay. Specifically, test yung workability. Again. Okay. So, define muna natin yung workability. So, workability class, so di ba, ang dami ng definition kanina class. So, eto na lang i-adapt natin class sa pinaka-formal definition natin. So, it is class the ability of concrete to be placed, compacted, and finished. Okay. Tapos, di ba, meron tayong factors. Ito nila. So, meron tayong factors class affecting workability. Okay. So, isa-isahin natin class. So, number 1, meron tayo ng water cement ratio. So, water cement ratio. Okay. So, ano yung significance class ng water cement ratio? So, supposedly class, higher water cement ratio gives us higher workability. Yan. Okay. So, number 2 factor class. Number 2 factor, meron tayo ng mixed proportion. Okay. So, ano naman class yung significance ng mixed proportion with regards to workability? So, same class, higher aggregate to cement ratio gives us higher workability. Okay. Tapos class number 3. So, third factor class is yung aggregate size. Aggregate size. Okay. So, in terms of aggregate size namang class, yeah. So, higher aggregate size class. Yeah, gives us higher workability rin. Okay. Tapos, fourth class. So, meron tayong fourth. So, meron tayo ng shape. Shape of aggregate. Okay. So, in terms of shape of aggregate class, yung rounded aggregate class gives us higher workability. Okay. Tapos, yung smooth surfaced aggregate. Smooth surface aggregate also gives us higher workability. Ayan. Okay. Tapos, second to the last factor natin class is grading of aggregate. In terms of grading of aggregate, okay. So, yung well-graded class, di ba? May well-graded. The higher the grading, it gives us higher workability. Okay. Number 6 naman class, lastly, syempre yung admixtures. Okay, admixtures. Okay. So, ano yung mga admixtures class that will, improve workability? So, meron tayo plus yung plasticizers. Plus yung mga air and training agents. Okay. Tapos lastly class yung mga puzzolanas. P yung atin. Puzzolanas. Okay. So this three class improves workability. Ayan. Okay. So that's it class for the definition of workability. That's the factors affecting. Okay. So yeah. So we jump naman in class dito sa ating slump test. So dito na tayo class sa measures of workability. Okay. So again class para mabilis, list ko na lang class, no? Tapos it will be discussed by the video. Tapos I will answer class our problem. So in terms of measures of workability, class scan ko lang, no? So first step class, meron tayong tinatawag na slump test. Okay. So in slump test class, it makes use of a mold. Ito. So mold. So technically, kung titignan nyo class, isa siyang cylindrical cone. It's a cone. Okay. Open at the top, tapos open at below. Okay. Tapos ito yung dimensions niya class. So meron tayong 100 dun sa upper diameter. Ang height niya class is 300 mm. Tapos meron siyang 200 bottom diameter. Okay. So, yan. Okay. So, panoorin natin class yung video. Doon tayo sa test. Ayan.
Concrete slump
So, unahin natin class again. Slump test.
test. Slump test is the most commonly used method of measuring the consistency of concrete work where the nominal maximum size of the aggregate does not exceed 38 millimeters. This method can be employed either in the laboratory or at the site. Apparatus required for slump test. The mold for the test specimen is in the form of the frustum of a cone having the bottom diameter of 20 centimeters, top diameter 10 centimeters, and height of the cone is 30 centimeters. A metal plate of thickness 1.6 millimeters is used as a base. A tamping rod of 16 millimeters diameter and 0.6 meters long is used. Let us now see the step-by-step procedure for concrete slump test.
So ito na yung procedure niya, class, no? Nung slump test natin.
The internal surface of the mold should be thoroughly cleaned and freed from moisture and any set concrete before commencing the test. The mold is placed on the smooth metal plate. The mold is filled in 4 layers, each approximately 1/4 of the height of the mold. Each layer should be tampered with 25 strokes with tamping rod, such that the strokes are distributed over the cross section. After the top layer is filled, the concrete is struck off level. The mold should be removed from the concrete by slowly raising in the vertical direction. Now, you will notice concrete tends to subside. This subsidence is referred as slump of concrete. This slump value is then measured by the difference of the height of the mold and
So ito, class, yung mini-measure, no? So di ba pagkaalis, class, nung slump cone natin, class, babalik ta rin mo siya. Tapos, yun, yung difference, class, nung height ng original slump cone dun sa nag-iba. Supposedly kasi bababa yung concrete natin, di ba? Yun na yung slump value natin. So we measure it, class, in terms of mm.
and that of the highest point of the specimen. This difference in height m is taken as slump of concrete. The pattern of a slump is displayed on the screen.
So supposedly, class, kung ano yung itsura, kung ano yung itsura nung parang bumabang concrete natin, says the, parang in a way, meron siyang tawag. Okay, so true slump, class, yung shear slump, tapos yung collapse slump. So technically, class, pag ganito kasi shear, di ba, parang yung, ganun yung failure niya ba? Shear. Okay. Tapos collapse. Okay. So technically, ang pinaka-gist ng slump, class, kapag gusto mong taasan, so supposedly, class, di ba, pag ganito kasi, di ba, mataas yung slump niya kasi measure natin from the original, pag ganyan. So malaki yung slump niya, no? So kung gusto mo, class, na bawasan yung slump, parang paliitin yung slump na yun, class, ang gagawin natin is, kailangan magdagdag ng semento. Okay? Kung gusto naman natin, class, na lakihan yung slump, supposedly, class, di ba, ganyan yung slump niya. Gusto mong dagdagan yung slump niya, class. So para lumaki yung slump niya, yung concrete na to, class, dadagdagan natin ng tubig. Okay? So again, class, to lessen the value of slump, you add cement. Okay? To lower naman, class, the value of slump, dagdagan mo ng tubig. Okay?
The slump value and its acceptable usage are.
So yung interpretation natin, class, ng slump value, dito yun sa dulo. Yan. Okay? So nasa table, table 4.7 tayo. So, andito siya, class, after nung tatlong tests. Okay? Sa kanya, class, hiniwalay niya ako, pinagsama-sama natin siya. Okay? Ito yung interpretations natin, class. Nung degree of workability. So, degree of workability, class, pwede lang siyang extremely low, very low, low, medium, or high. Okay? Okay, yan. Ito. So, parang ganito yung galawan natin, class, dun sa slump test. Okay?
Tabulated on the screen. Thank you for watching. Stay tuned. The best is yet to come.
So ituloy-tuloy na natin, class. I-summarize ko na lang ng isahan. Okay? So ang next step, class, after ng slump test, ito supposedly, class, is more precise and sensitive than slump test. Meron tayong tinatawag, class, na compacting factor test. Okay? So supposedly, class, ganito yung setup natin. Meron tayong tinatawag, class, na conical hopper. Meron tayong conical hopper na dalawa. Okay? Tapos meron tayong trapdoor. Supposedly, trapdoor, class, no, open yan para mag-slide kung ano man yung concrete na linagay natin. So, dalawang conical hopper, class, is isang cylinder. Okay? Supposedly, class, ito, parang twice natin gagawin. Okay? Ay, i-discuss naman dun sa video mamaya. Pero ganun, class. So, papadaanin yung class, yung concrete through those two hoppers, class. Tapos, pupunta sa cylinder. You wait, class, yung cylinder na yan. Okay? Next up, class, second time, parang i-ano natin, class. Iko-compact natin yung cylinder. Tapos i-compare natin, class, yung ito. I-compare natin yung weight ng partially compacted. So yun yung first, yung parang nahulog lang siya ng nahulog dun sa dalawang hopper into the cylinder. Tapos dun sa fully compacted. So yung fully compacted, plus yung nahulog dun sa cylinder, iko-compact natin using Yun, dumping rod. Okay, so ito class yung mas detailed explanation.
Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. Compaction factor test for concrete. The compaction factor test is designed generally for use in the laboratory, sometimes used in sites. This test has an advantage of using this method for concrete mixes of very low workability. The compaction factor apparatus consists of the upper hopper of dimensions: top internal diameter 25.4 centimeters, bottom internal diameter 12.7 centimeters, and internal height 27.9 centimeters. A fixed lower hopper of dimensions: top internal diameter 22.9 centimeters, bottom internal diameter 12.7 centimeters, and internal height 22.9 centimeters.
So yun class, kung interested kayo dun sa dimensions niya, dito siya. Okay.
And a cylinder C of internal diameter 15.2 centimeters and internal height 30.5 centimeters. The distance between upper and lower hoppers and lower hopper and cylinder is 20.3 centimeters. Procedure. The sample of concrete to be tested is placed in the upper hopper up to the brim. The trap door is opened so that the concrete falls into the lower hopper. Then, the trapdoor of the lower hopper is opened and the concrete is allowed to fall into the cylinder. The excess concrete in the cylinder is leveled.
So yan yun class, no? So yun yung parang first dive niya. Supposedly class, yung nahulog na concrete from two conical hoppers class, yun na yung partially compacted concrete natin.
The outside of the cylinder is wiped clean. Now, the cylinder filled with concrete is weighted. This weight is known as the weight of partially compacted concrete. Then, empty and clean the entire cylinder. Now, fill the cylinder with concrete in layers where each approximately is 5 centimeters deep. Once fully filled, the top surface is leveled off. The outside of cylinder is wiped. Now, weight the cylinder. This weight is known as the weight of fully compacted concrete. The compaction factor is equal to the ratio of the weight of partially compacted concrete with the weight of fully compacted concrete.
So yun class, no? So kung compare natin class yung slump test kanina, ang data natin kasi is in terms of millimeter. Okay? Dito naman class sa compacting factor test, okay? In terms of compaction factor tayo. So titignan ko as unit class tayo. Pero meron tayong value class which is the ratio of the partially compacted concrete tsaka yung weight ng fully compacted. Okay?
With the help of compaction factor value, the degree of workability is calculated with the help of the table. Thank you for watching. Stay tuned. The best is...
So again class, yung sa atin nasa dulo, no? Ito. Naka-consolidate siya into one table. So ito yung sa slump, ito yung sa compacting factor. Okay. Tapos lastly class is yung sa VB consistometer method. Okay. So dito naman class, ang galawan natin, meron tayo ng VB consistometer. Okay. So ang galawan dito class, in terms of time tayo. Okay. So supposedly class yung cone, ito. So yung slump cone natin class, gagamitin natin dito sa VB consistometer. So yung slump cone na yung class, lalagyan natin ng concrete gamit yung funnel. Okay. Tapos aalisin mo siya. Tapos ilalagay natin ito, class disk dun. Hindi ko alam kung bakit, pero yun. Tapos kung titignan nyo kasi ito yung platform na yung class, parang vibrator yan. So, iba-vibrate niya yung class hanggang sa yung slump cone natin. Kung titignan, pag inalis yung slump kasi, parang in a way bundok yan. Okay. I-on natin yung vibrator class hanggang sa maging flat siya. Kumbaga mag-settle siya dun sa ating cylinder. Okay. So, yun yung i-measure natin na time. The time class from inalis natin yung cone hanggang sa maging fully level siya dun sa ating cylinder. Okay? Yun na yung data natin for the VB consistometer. So, para mas detailed class, panoorin natin to.
Is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. VB consistometer test for concrete. VB consistometer test is used to determine the mobility and compactability of concrete. The VB consistometer test consists of a vibrator table resting upon elastic supports, a metal pot, a sheet metal cone open at both ends and a graduated rod connected with glass disc. The entire setup is shown on the screen. For dimensions of the various shapes are designed based on the IS 11991959. Today, we are not going to concentrate on dimension. Let us now start with the procedure. Place the slump cone inside the cylinder. Now, fill the concrete in 4 layers. Each concrete is 1/4 of cone height and damper the surface 25 times. Once filled, struck off the excess concrete. Move the glass disc attached to the swivel arm and place it on the slump cone such that
So yan na yun class, diba? Nalagyan na natin yung slump cone natin. Okay.
it touches
Yan.
the top of the concrete level. Note down the reading in the graduated rod. Next, remove the cylindrical cone by raising the cone slowly in the vertical direction. Again, place the glass disc and determine the reading. Now, switch on the electrical vibrator and at the same time switch on the stopwatch. The concrete will start to spread in the cylinder container. Continue the vibration until the concrete is remolded and the surface of the concrete becomes horizontal. Stop the vibration and stopwatch. The time in the stopwatch denotes the workability of concrete. The time is expressed in VB seconds. Calculations in VB consistometer. Initial reading in the graduated scale before remolding AM. Final reading in the graduated scale after remolding BM. Slump value is equal to a minus PM. And the consistency of the concrete is measured in VB seconds. The workability conditions with respect to VB.
So ito yun class. So again, ganun tayo, no? Into 1 lang tayo. Ito lang lahat yun. Okay. So i-summarize natin lahat class. Mabilis ang summary. Okay. So again class, andito na tayo sa measure. Ay. Oo. So measure of workability. Okay. So again class, di ba, unahin natin, meron tayong slump test. Yes, okay. So in terms of slump test class, it is measured in, ito class measured in millimeter tayo dito. Okay. Yeah, so it is measured class in millimeter. So supposedly class dapat aggregate size natin dito be less than 30 millimeter. Okay. So ang gamit natin dito class is yung slump cone. Slump cone. Okay. So yan. Okay. Tapos itong slump natin class, di ba? I-measure natin yan. Supposedly, di ba, pag ito na yung ground level class, no? Ito yung inverted slump cone natin. Tapos ito na yung nag-slump. So ang mini-measure natin class is ito. Tapos yun. Okay. So ito na class yung ating slump. Okay. So again class, in terms of mm tayo dyan. So sundan natin yung next class para matapos na. So next up class, meron tayong tinatawag na compacting factor test. Compacting factor test. Okay. So in a way class, ang compacting factor test, goods daw to class for medium to low. So supposedly class is from medium to low workabilities. Okay. Tapos it is measured. So yung data natin class is measured in yung compacting factor natin. Compacting factor ratio. Okay. Where in class, yung compacting factor ratio natin class, so yung CF is equal to class yung weight ng partially compacted Okay. All over class yung weight ng fully compacted. Okay. Tapos class letter C, yung last na measure natin class ng workability is yung VB. VB consistometer method. Consistometer. Sabihin na lang natin test para consistent tayo. Okay. So supposedly class, ito is measured in yun, VB seconds or simply seconds lang siya class. Seconds. Okay. Tapos parang in a way class, it is the measure of, yeah. Pero pinaka-measure talaga dito class is yung consistency. Consistency of concrete. Okay. Or ano ba ang consistency class? It is the ability to flow. So besides workability class, yun din, minimeasure yung consistency. Ability to flow. Yan. Okay? So again, class, ito yung interpretation natin. So para makuha natin class yung degree of workability in terms of yung slump test yung gamit natin, yung compacting factor, yung PV. So yan. Okay? So depende na dun class kung ano yung mga nakuha natin dito. Okay, ang interpretation natin class is ito. Degree of workability. As may second part siya class yan. Ano yung uses niya given the degree of workability. Okay? Tapos syempre class yung pinaka-characteristic ng concrete natin. Yan. Okay? So with that said class, sagutin na natin yung problem para maka-move on tayo. Okay? So with this class, meron tayong problem or example 4.2. Okay? So meron tayong example 4.2. Okay? So for the example 4.2 daw class, given or the actual data from a slump test. So usapang slump test tayo, no? So determine class the degree of workability of each concrete mix and choose which one to use in the concrete pouring of second floor beam slab. Okay, tapos examining concrete mix 1 class, should you add water or cement for it to be suitable for concrete pouring underwater? Okay? So given muna tayo class. So ano yung given natin? So supposedly, ito. So hindi ko nasusulat yung given. Ay, ano ko na lang yung required class. Okay, so what are the required class? So hinahanap natin class degree of workability. Okay. So in a way, class meron tayong tatlong given. So degree of workability. Okay. Tapos yung, yun. Anong concrete mix daw class? Concrete mix for yung second floor beam and slab. Okay? Okay. Tapos yun, examining concrete mix 1 class. So in concrete mix 1, add, anong idadagdag natin class? Water, H2O, or cement. Ayan. Okay. So, yan. So, unahin natin class yung letter A. Iwalay na lang natin class. So, sabihin natin ito yung A, meaning yung degree of workability class. So, in terms of degree of workability class, given yung concrete mix, gawin natin itong blue. So, concrete mix natin class, no? Tapos, yung slump. Okay. Tapos, ano ito na yung degree of workability. Of workability. Okay. So, kaya natin given class. So, again, concrete mix 1, concrete mix 2, concrete mix 3. Okay. So, meron tayong 27 mm. Okay. 55 mm. Tapos, 25 mm. Okay. So, dito class, gagamitin lang natin yung table kanina. Ito. So, yan. Simple lang naman class. So, for the slump class, ano yung degree of workability? So, titignan mo lang class saan siya saan range siya. So, titignan nyo class 27. So, andito siya. So, ang sagot natin dito class is low. Kasi within 1, 27 to 50 siya. Same dito class. So, 55 is within 51 to 1. So, medium. Okay. Tapos, yung 25 class is within, ito, very low. So, yun na yun, class. Okay. Tapos, second question, class, choose which one to use in terms of yung, ito, yung second floor, beams, and slab. Okay. So, dito naman na natin gagamitin, class, yung, ito, yung second table. So, kung titignan natin, class, saan ba nagpo-fault, class, yung second floor, slab, tsaka beam. So, dito dapat siya, class, sa normal purposes. Okay. So, see, yun nga. Paano ba natin isulat? So, second floor, beam, saka yung slab. Okay. It falls under class normal purposes. Ito. So, normal purposes. Okay. Specifically class under dapat medium. Dapat sa medium form of workability. Okay. So, anong mix ba ang may medium degree of workability class? So, dito tayo sa concrete mix 2. Okay. So, ang sagot natin dito class is yung concrete mix 2. Okay. Kasi meron siya class 55 mm slab. Na slab. Okay. Tapos for question B. So ano ba yung question? Next question. Should you add water or cement? So sa concrete mix 1, no? So yeah. So si concrete mix 1, ang slump niya class diba is 27 mm. Okay. So dapat daw class, what will we do? Mag-add ba tayo ng cement to be suitable for concrete underwater? So, then second class, di ba? So, titignan nyo class, for it to be suitable for concrete placing underwater, dapat ang workability niya is high. Okay. So, ano ba yung high class, no? So, sulat muna natin yung underwater. So, diba? Underwater concreting class. Supposedly mag-fall siya sa high. Okay. Which is equal to class sa range na 101 to 175 mm. Okay. So, kailangan natin class, paano natin gagawin? So, kung titingnan nyo class, para mag-fall siya dun sa high na degree of workability, kailangan natin pataasin. So, paano pataasin class? Add water or cement? So, di ba, again, class, ang slump natin class. Di ba, ito. So, ito yung ground surface. Okay. Ito yung bundok. Supposedly, class, ito yung slump natin. Okay. So, pag dagdagan natin ng tubig to class, mas bababa yung concrete mix natin class, diba? Okay. Pag dinagdagan natin ng semento yan class, mas liliit yung slump natin. So, kung gusto natin class na lumaki yung slump, okay. So, parang ito yung class for us. Para lumaki yung slump, add water. Add water tayo class. Kasi mas babagsak yung concrete mix natin class. Mas lalaki yung slump. Okay. Kung gusto naman natin class na bumaba yung slump, so add cement. Okay. So again class, di ba? Ang original concrete mix natin class is ganyan. So para mapataas natin class dun sa kailangan nating palakihin yung slump. Okay. So ang conclusion natin dito class, yun. Kailangan natin class mag-add ng water. Okay? So yun yung sagot class dito sa question. Should you add water or cement? Okay? So for it class to be suitable for underwater concreting class, dapat pasok tayo dun sa ganun. So dapat lumaki yung slump niya class. So fix natin class is to add water. Okay? So yun class, that's it. So kung titignan nyo yan, tama yung sagot natin, no? So for the concrete mix 2 class, tama. Tapos low, medium, very low. Tapos we should add water. Okay? So we stop here class. This will be part 6 of module 4. Okay? For part 7 class, the last part of module 4, we are to discuss strength. Okay? So again class, that's it. Thank you for staying. See me at the next video. Bye.